Hi everybody, Steven here. So continue on with our performance series. This is part 6, and this is going to talk about networking performance. What should we watch for? What are things that we need to know that's really important when we talk about performance? So stick around and we'll see you in a bit. Bye now. Thanks for sticking around, everybody. So what we're going to take a look at here is network performance. Some of the more common things that you need to look for and some of the most common stuff that you need to be aware of. These common things are overlooked quite easily, to be honest with you. I always like to throw this out at this point. If this is kind of content you like, please subscribe to the channel. Support the channel by subscribing to it. It's free. Just click that subscribe button. Another way to support the channel is super thanks. Totally up to you. All right. Also share the videos. That also helps out with the analytics and liking video if you found it entertaining. So this is going to be a lecture demo type thing, just like I've been doing in the past. So let's jump right into it. So let's get my iPad going here. So let's talk about network performance. All right. Now, the first thing we got to do, and if you want learn more about virtual networking in vSphere, I'll leave a link towards that at the end of this video where you look at virtual switches and stuff that I made. And I actually go through a lot of that stuff in quite detail. But this is the type of network drivers that you get a choice of selecting from, right? When you create your VM, you're giving it a virtual NIC. So these are the options that are available. Now, some of these options are available depending on the operating system you select and depending on the hardware version of the VM. Like, oh, if I've got an older ESX, whatever, 3.x server or 8.x, that type of thing, right? So the first one here we look at is VLANs. VLANs is a generic AMD. This is this is like one of the first ones that came out with an ESX 1.1 type of thing way back years ago. This is basically a 10 megabits, not gigabits, 10 megabit driver that was found in most operating systems of the day. For example, like OS2 or something like that. So great. Then there was VMXNet. So these were the first two that came out. Those were your choices back in, like I said, the 1.x days. I believe 2.x days, if I remember correctly, right? The VMXNet now is a pair virtualized driver. Basically, it's a driver supplied by this thing called VMware Tools, and it's to give you more performance than the old 10 megabits. So that's what we had back in the day. You would pick one or the other, right? And I remember teaching classes. Okay, which one do I pick? Well, it depends on basically what operating system you have. So, for example, OS2 wasn't supported as a VM then. So if I was installing OS2, which I've done back in the day inside a VM, I knew VMXNet wasn't available for it, so I would pick VLANs, right? And that was my only choice. Anyways, enough of that. Then it kind of came up to this one called flexible. So you generally don't see these ones there. It's not visible to you. You see flexible and you go, what's flexible? Flexible means when you select flexible and you boot and you go to install the operating system, what happens is it recognizes the AMD. It'll use the VLANs driver first. Let me clear up this. It uses the VLANs driver first. Then after you get your operating system installed, and it will see a network card, an AMD network card, then when you install VMware Tools, it'll switch it over to the VMXNet. So that was flexible, right? So it kind of made things a little bit easier. Generally, you're probably not doing this today unless you're installing an operating system that's not supported. Like if I want to install OS2, let's say, I would get the choice of flexible there, right? The E1000 is a version of the Intel 82545 EM gigabit card. Again, this was available for most operating systems. I give an example of XP here. Great. So again, if you install your operating system, it would automatically see this Intel card. Beautiful. Then there was the E1000E, which is just an enhanced version of that card. And again, that's generally found in newer Windows operating systems. So if I install Windows, and you'll see that in my demo, like if I install Windows 10, it comes up and it defaults to the E1000E. All right. Now, VMXNet 2 was an enhanced version of VMXNet. And this came out, I can't remember what version. Might have been version 3, I think, maybe version 2. Who cares? It's years ago, right? That came out, and it was an enhanced version of VMXNet, and they gave us certain features. One of the big features was jumbo frames. So there it goes. Yeah, it came out in 3.5 or later. All right? So that's good. Then the one that you want to select is VMX-Net3. This is a paravirtualized NIC driver. Basically, paravirtualized means it's aware it's a virtual NIC. All right. This gives us other enhanced features, jumbo frames, and all these wonderful things. So this is the one that you want to select. Okay, that's the one that you want to select for pretty much all your workloads. This does require VMware tools, just like the VMX-Net. Okay, so again, you'll see in my demo, I actually go with the default at E1000 in Windows 10. I do some performance runs, and then I switch it over to the VMX-Net, and I show you how to do that, and then we just see what the differences are. Now, there's also this one called paravirtualized RDMA, paravirtualized remote direct memory access. This is generally available for Linux operating systems with kernel 4.6 or higher. This is more of a specialty case. There's white papers on this. If you're creating a high performance compute cluster, let's say, using VMs, and you want to get that low latency kind of traffic between them. So this is an option. So if you were installing Windows as your operating system, you wouldn't see this as a choice. Let me show you this just real quickly. All right, let's create a VM real quickly here. New VM, I'm not going to care about the name of it. I'll pick it on that host. I'll put it on my vSAN data store. I don't care. I'll leave it at VSX8. I'll pick Windows as my default. I don't care. And over here underneath my network, I expand that. You see it picks E1000, right? E. And then you get E1000 as a choice, PCI pass-through. I'll talk about that briefly. Actually, let's select that. If I come up, it comes up, it gives me an error. SRIOV, hardware not available. Single root IO virtualization. I'll touch on that a bit. But notice again, it comes up with an error. Or it gives me the choice of VMX-Net3, which again, you want to pick, all right? There are situations where you may want to pick this one. I'll talk about that one later, okay? But okay, those are our choices here. We only see the 4. Let's back up the screen. Let's go to Linux. Let's go to other. Let's go to, hey, good old OS2. It's going to make a comeback, folks. I used to use OS2 on a daily basis at work. And anyways, no jokes about that one. Adapter, notice it says flexible here, or E1000, which I'm actually amazed. Maybe that wasn't the newer version of OS2, but anyways, doesn't matter. So the flexible, again, gives me the AMD to begin with, then it changes it over to VMX-Net once I install VMware tools. Okay, great, enough of that. Let me back that up. How about if, I don't even think they got DOS here. What about other 32-bit? If I pick that and go next, you see under network adapter, flexible, you see a whole bunch of stuff here, right? Because it doesn't know what it's got, right? So anyways, I want to show you one more. Let's go to Linux. I'm just going to pick SUSE Enterprise. And I go next. And then when I look under network adapters here, I see VMX-Net3, E1000, the paravirtualized remote direct memory access. So you only see that under the Linux one, that later version, okay? Again, that's that specialty type one, okay? I'm going to cancel that. Let's go back to the iPad. Now, single root IO virtualization, I'll talk about that in a second, okay? There's pass-through and single root. Basically, in a quick nutshell, it's the ability to map a physical card to a VM, all right? So let's go through that. Let's take a look at now some performance features that you should be aware of. Now, most of these are available inside the physical NICs. So again, TCP segment offloading. These are features, and they talk more about it in this article right here. TCP segment offloading, it says the NIC divides larger data chunks into TCP segments. So basically, you got your maximum transmission unit size. Generally, it's like 1500 it defaults at. So your NIC basically would take the large frames and then, or segments, and then or packets, and put it into, actually it shouldn't be packets. Anyways, it doesn't matter. And it would put it into the smaller segment sizes, to the 1500. So generally the CPU's doing that. If your card supports this TCP segment offloading, the NIC does that. So that offloads processing from the CPU. So that's a good thing. The reverse of that is large receive offload, reassembles the incoming packets into large buffers, resulting in fewer packets for the CPU to process. So instead of me putting small packets in a buffer each time, and I got to tap on the shoulder of the CPU and say, hey, I need you to do this, I need you to do this, we'll just put it into a large buffer and say, here, look after this big chunk. Boom. Here, look after this big chunk. That's kind of the idea. So these two features allows us to not interrupt the CPU as often. NetQ, the ability for a NIC to deliver Network traffic to the system in multiple queues. Hey, what's better than one queue? Two queues, right? So if you got multiple queues, that's kind of better. The advantage of this is now we can have multiple processors, physical processors looking after that if this is supported. Most of the times these features, if your card has it, the system sees it, it's automatically enabled. Split receive mode. This is only available to the VMs that have the VMX-Net3 drivers. Now, there's a couple of use cases for this, and they've got some knowledge base articles on it. But again, if your VM's got a lot of multicast traffic, this is something you want to look at. It says multiple CPUs can be used to process packets in a single queue. So we got one queue now, but we got multiple CPUs, physical CPUs processing. So that's good. But remember, you're tying up your processors doing that, right? Improves performance of workload, typically multicast traffic. Again, with VMs, multicast traffic with VMs on the same host. Automatically activated if the physical NIC, 1, is heavily used, and 2, more than 10,000 broadcast or multicast packets per second. So this is good for broadcast and multicast. And this will automatically be enabled. You can activate this on an individual virtual NIC if you want to. So you can go into your VM, if it's Windows or Linux, if you know you fall into this category, you can say, I don't want it automatically activated at this point. I want it automatically activated as soon as I turn it on. So you can modify that, and there's knowledge base articles on it. Jumbo frames. Jumbo frames allows us to, you got your maximum transmission unit size, 1,500 bytes. Well, that's basically, think of this as you got a little train car. You're moving 1,500 bytes at a time through your network, right? Well, let's increase that now to 9,000 bytes. Now you're moving bigger chunks of data through your network. So up to 9,000 bytes. Notice again, the E1000s and the VMX-Net2 and 3 drivers support that, okay? So you need end-to-end support. That means your physical network needs to support these jumbo frames. If not, if your VM is sending out a 9,000 byte package or frame, at that point, what's happening is your network will receive and say, oh, we can't support that. And it's going to fragment. It's going to take that 9,000 and chop it up into 1,500. In other words, you're basically making things worse. So don't just enable jumbo frames inside the driver of your virtual NIC. You've got to make sure your physical network supports it end to end. So if it's starting here and it's ending here, it's got to support it. Else you're just spinning your wheels and wasting time. So MTU up to 9,000 bytes. For high packet rates and low latency. So if you're in a situation where you need these really high, you don't care about actual throughput, you care more about the number of packets going through the pipe as opposed to megabits per second, right? This is stuff like telcos may care about stuff like this. I'm not a telco guy by any means. So you really care about pumping lots and lots of packets through that card, and you want really low latency. Then one of the bad things about a virtual NIC is it's virtualized. So you have to go through the virtualization stack. That adds a little bit of latency there. For most of us, we don't notice it. It doesn't matter. But for certain applications or workloads, that may matter. So these technologies, single root I/O virtualization and direct path I/O, allows us to map a physical card to your VM. What's better than that? Well, there's issues with that. Stuff like vMotion doesn't work. There are certain limitations that you got to be really aware of if you're going to do this, okay? But now what's the difference between both of them? Single root I/O allows for a single physical NIC to be shared among VMs, and direct path I/O maps a physical NIC to a single VM. So the first one is you got multiple VMs sharing this physical NIC, which makes more sense. Or you direct path I/O, again, that was the one that came out first, I believe. You can give a physical NIC to one VM only, and that's it, okay? Nobody else could share it. So I think this is more of a, I don't want to say niche market, but if you're a telco, you're probably going to be doing stuff like this, right? But anyways, these are some stuff that you could be aware of to help you with your performance. Now, what should we watch for? For the most part, this is pretty straightforward. You got the packets transmitted per second. This is using ESX top or RSX top. And again, you use N for the networking view, which I'll demo. And I'll show you these. So you got packets transmitted, packets received. Megabits per second transmitted, megabits per second received. Pretty straightforward. And these two are probably the big ones here to see if you're having issues. The percentage drop transmit and the percentage drop received, right? Oh, I made a mistake here. This one here, I just realized that. That should say percent drop received RT. So I made a mistake. I just realized that. So if you're dropping packets, if this number is 1, you got a problem, all right? That's going to impact performance. So you don't want to be dropping packets. Now, the telltale sign is, am I dropping transmits or receives? General rule of thumb, if you're dropping transmits, a lot of, like, you notice you're dropping transmits, that usually indicates a problem in the outside world. Your outside network is saturated. It can't handle the traffic, right? If you're dropping packets coming in, receives, that usually indicates maybe a problem on the inside. Maybe your CPUs, maybe your CPUs are also stressed, right? Okay, remember the CPUs get involved with this. They could be stressed and they could be dropping packets, right? Again, if you put limits and stuff like that, remember with shares, limits, and reservations, you put limits, we could drop packets on that too, right? So watch out for that. So these are telltale signs if you've got a problem. Megabits per second transmitted and received. Again, this is going to depend on your network card as well, right? Now, what can we do? I'm going to show you a demo on this in a second, but what can we do? What are some suggestions, possible suggestions to fix this? Again, I already mentioned this. Use VMX-Net3 wherever possible, all right? Don't go with the default E1000. You'll see me do a comparison between the two. By the way, I'll mention that in a second. Move virtual NICs, more virtual NICs to the VM, right? So you only got one virtual NIC in the VM, maybe add a second or third. Hang on a second. If you've got the VMX-Net3 driver, it does really have an upper limit, somewhere around 9 to 9.5 gigabits per second. So if your VM needs to support more traffic than that, like I know in our NSX edges, we can have multiple upstream NICs using VMX-Net3. So you can get, let's say, now you got 2 NICs, 9.5 gig each, so you get about almost 20 gig throughput, like 18.5 or whatever, right? So this might be an option for you. That's why I got question marks there. Bigger, faster NICs. If you find that, my 10 gig cards aren't doing it, you might got to get 40 gig cards. Use separate virtual switches and dedicate NICs for VM kernel traffic and VM. Now, ideally in the perfect world would have separate physical networks for everything, but nobody can do that, right? But really what you want to try and do is completely have your VM traffic physically isolated from your VM kernel traffic, like your vMotion, your management, vSAN, that type of thing. I think I mentioned vSAN down here. If you're playing with vSAN, yeah, you want to have a completely private network for vSAN, if possible. Sometimes that's not possible, right? Use physical NICs that support the advanced features that I just talked about. Most server NICs support that, but generally you may want to look at that. Now, if you're in a situation, there's a thing called network I/O control. That allows you to do shares, limits, and reservations on port groups. And this is only available on virtual distributed switches. Okay, so if you got a situation, for example, let's say my server only got 2 10 gig cards. That's all it's got, and it's got to do management traffic, vSAN traffic, or whatever, vMotion traffic, virtual machine traffic. This is where you can use network I/O control to actually go in and kind of carve up that bandwidth. And again, like I said, you can do shares, limits, and reservations. Reservations I'm always really scared about. People just blindly jump in and they end up shooting themselves in the foot. So watch out for that. Now, you'll also see suggestions of doing NIC teaming to help you with performance. And that kind of makes sense at the first, thought of that. And that makes sense. But let's look at this slide. Now, I'm not going to go through NIC teaming in general. I talk about that in my networking video. I'll leave a link towards that at the end of the videos for you to watch, right? But when you talk about NIC teaming with virtual switches, you got explicit failover. Really simple. You got one network card is active, the other is standby. So if you got 2 10 gig cards, one's active, all the traffic's going through the first card, and the second card just sitting there in case the first card fails. Obviously, that's not going to help you with performance because the second card's sitting there doing nothing, okay? But it's more for failover, right? For high availability. How about route based on originating port or route based on source MAC? Again, I talk in depth about those in that video. What that means is, we got the 2 10 gig cards. That means some VMs will use the first card, some VMs will use the second card, all right? So that sounds pretty cool. So we're sort of splitting the traffic across the cards. and it's based on either the VM's MAC or the port that it's plugged into. That sounds really good. But the problem is, so you got two 10 gig guards, and some VMs are using both, or some VMs are using one, some VMs are using the other, which is great. But if there's a card failure, boom, now all that traffic's going through one card. Can that handle that traffic? So that's the thing you got to keep in your back of your mind. And a failure, if everybody now goes to one card, well, performance is okay with the two, but you fail, can the one card handle the traffic? Same thing with the route based on IP hash. This requires Link Aggregation Control Protocol, LECP, 802.380 link aggregation on your physical switches. So you need to set this up on your physical switch. Again, most network guys are quite familiar. Same kind of concept here. It will do, again, I don't want to say load balancing. It does distribution across, let's say, your two NICs. And great, everything's looking good, right? And you can do that based on source and destination IP, whatever, anyways. But again, it comes down to if one NIC fails, also performance was fine on everything, but one NIC fails, can that single NIC handle the capacity for all the other VMs? So these you got to keep in the back of your mind. A route based on physical NIC load. This is load-based teaming, right? Only available on the virtual distributed switch. It's sort of, let me clear this. It's sort of an offshoot of these guys. Remember I said this one up here, some VMs will use the first NIC and some VMs will use the second. Well, if that first NIC is oversubscribed, it doesn't care. The second NIC could be, not being used that much. So it doesn't look at the workload on the physical NIC. This here, route based on physical NIC load, is sort of an offshoot of this guy. It will say, okay, some VMs will use the first NIC, some will use the second. Then it looks at the card every 30 seconds, I believe, and it says, oh, I've hit 75% capacity of this first card. I better move some VMs over to the second card here. So it looks at the performance of both cards, and it tries to make sure that they're operating almost at the same level. That's kind of the idea. So it's sort of an intelligence version. It's sort of an intelligent version of route based on port. Okay. Again, the same thing applies. NIC teaming doesn't just fix your performance issue. Again, if that second NIC fails, can that first NIC handle the workload? So again, this here NIC teaming, you'll see this as a suggestion, but again, you got to keep in the back of your mind. Yeah, that helps my problem today, but if a card fails, I may have a performance issue. So you got to keep that in the back of your mind. All right. That's it. Stick around and watch the demo. By the way, if you haven't subscribed to the channel and you kind of like this stuff, hit the thumbs up. And if you haven't subscribed, hit that subscribe button. I'd really appreciate it. See you in a bit. Okay, so let's take a look at my environment. I don't really have anything too crazy here. I've got my old clusters from before. Again, it's just an SD-WAN, SD-WAN. It's a vSAN cluster. I got two Windows VMs running. I've got a utility there called Iometer, which I'm going to use. I've used it for storage. I'll use it to stress the disk. Now, let's first look at some of the stuff that we can see from a network perspective. Let me go to host 1, and let's log in as root. One bang, and I'm going to change the fonts and all that wonderful stuff, again, as usual. So let's change the appearance. Let's crank it up a bit so we can see it a little bit better. Let's change the background color. And I like that color there. So we'll say OK and apply. And away we go. All right. So now, let's go here. All right. So I'm going to type in ESX top. And again, you can use the GUI if you want to. Again, we're looking at CPU over here. Both of my VMs are going to be running on ESX top here, by the way, or sorry, on host 1. Let me show you. Win 1 over here is on host ESXi01. Win 2, let's just make sure it's on ESXi01, okay? I had set it up like that. We're looking at CPU here as soon as you fire up ESX top, so I don't want to look at that. I want to look at N for network. And you see a whole bunch of stuff over here, right? Let me just open this window up a little bit more. Okay. And you'll actually see, again, we've got my VMNIC 0, 1, 2, and 3. These are the physical NICs inside your host. Okay, you'll see one of them is actually doing a lot of work. Again, I believe that's my vSAN network. Let's leave that one alone for now. So you can quickly look and see which NICs are actually really busy, right? Just by looking here, which physical NICs. Here are my two Windows VMs. Let's just look at Win 1, for example. You see it's bound to VMNIC 0 right now, and Win 2 is bound to VMNIC 0, right? just the way my lab is. Your lab, it could be different. It could be VMNIC 2, 3, 4, whatever the case may be, right? You'll see the packets. You'll see over here packets transmitted, this column here. You see megabytes transmitted per second. You'll see the packet size transmitted, packets received per second, megabytes received per second, and packet size received. So we see both packet sent and received. We see megabytes sent and received, and we see the packet size sent and received. Okay. Then you see over here the drop transmits and the dropped receives. That's the important column. So if I hit F for other fields, you'll see there's other stuff I can look at if I want to look at actions or multicast or broadcast traffic. If I put in P and Q here, if I hit P and then, oops, sorry. Let's try back that again. Network, fields, and then I'm going to hit letter P and then the letter Q to turn those on. And you'll see I get more fields here for multicast and broadcast if you want to troubleshoot that. I'm going to get rid of that. I don't care my particular lab here or right now. Okay. So one of the big counters you want to look for is dropped packets transmitted or received. Okay, which I kind of mentioned before. Now, when we talk about dropped packets, it's important to know which one is which. If you're dropping more transmit packets going out in the real world, that could indicate your real world saturated or a problem in the real world. It could be a cable card port or whatever. You're dropping stuff. It usually indicates a problem there. Okay, usually. If you're dropping received packets coming in, again, it could be a cable, whatever, card or something like that, but usually that indicates that your host is having a hard time processing those things, and so you could be CPU intensive. If I hit C for CPU, again, I'm not really going too crazy right now. It's not too bad, but if your CPU is pegged, you're very CPU bound, that could be a reason why you're dropping receive. So again, transmits usually indicates maybe a problem out there. Receives could indicate a problem inside. Okay, that's a generalized look at that. Okay, you'll notice. Let me just get back to here. My VM kernel 1 over here. There's a lot of traffic going over that. It's actually the same as my VMNIC 3. I know that that's my vSAN traffic. Okay, how do I know that? Let me just go in. I said VMNIC 1, right? Let me go to host 1. Let's go into my configure. Let's go into VM kernel adapters. VM kernel adapters, port group vSAN. It's a vSAN. I don't have any vMotion. If I had a vMotion VM kernel port here, in my lab I don't have one right now, but if I had a vMotion one, I could see the vMotion. I could look at traffic on that too, right? So again, it's kind of showing me some of the stuff here, which is kind of neat. All right, let's get a little bit of traffic generated here. Okay, so let's go back into here. Let's go into Win1. Actually, I'm already on Win1. Let's go to Win2, and I got a CPU. Again, it's probably just because it booted up that that long ago. Let me close that tab. Let's go back to Win2. I want to flip these around. There we go. So Win2. Let's log into Win2. All right, so what I want to do is I want to generate some traffic between the two VMs. And there's various ways to do this. I'm just going to use Iometer, right? So Iometer is what I call it. So I'm going to fire it up on Win1. Great, there we go, it's fired up. Now I'm going to go to Win2, and I need to run, again, this is a client-server type. Don't worry about that. I've been doing distressing. It's client-server technology, right? So I'm going to go to Win2, and from a command prompt, I got to run this command called Dynamo. So first of all, I need to know the IP address. So ipconfig. This is 179. Let me just make the note of this: 179 Win2 W2, and this one here W1. Is 144 W1. Okay. Let's go back to Win2. Let's run dynamo.exe-i 192.168.70. And again, this is 179, so it's the other one. So it'll be 144-m 92.168.70. And this is, again, would be this machine here, 179. Hopefully I got that right. And I can say, yes, I want to run Dynamo. All right, and if I go to Win1 now, if I go back to Iometer, you'll see that I actually added another manager here. Now these have workers. Because I have dual virtual CPUs in these, as you see, 2 workers each. So I'm just going to actually delete those. Those are for disk. I'm not doing disk. Did that in another video. Now I'm going to go to my first one here, and I'm going to add in a network worker. That's what this little network one looks like. So I'll hit that, and I want it to be this guy here is 144. So I want to go to 179, right? So I'm going to go to 179, and it's using this network card on this machine. Now I'm going to go access specifications. From here, I have to assign one of these access. How do I want to do random reads, writes, whatever? I want to kind of stress it as much as I can. So I'm going to pick this 4K aligned 100% read, but I'm going to edit this. And I'm going to say I want it to do, instead of random, I want to do sequential. Okay? So it's going to do sequential. I'll say OK. And then I'm going to add that to this worker. So now this worker is using that access specification. I just hit the go flag. I'll also hit go. And then at that point, I'll save the results. Again, this goes to a CSV file. You can actually look at your stuff if you're doing benchmarking in production or something. I'm going to change this update frequency every 5 seconds. I don't want to do it every second because then that stresses the virtual CPU. I got both of them running on this host here. Notice I'm getting about 100. I should let this settle down for a little bit, right? So it's hit 191. Actually, I should change this. Actually, no, we'll just leave it like that. Actually, no, let's change it to reads per second. There we go. So we're at 96 megabytes, 101. We'll give it a few. All right. Now this megabytes per second. All right. So I take this number, multiply it by 8. So 100 and it just went up to 150. Let me get my calculator there. 150 times 8, about 1.2 gigabits per second. We're at 160 now. It's slowly creeping up. 170. It's going up to, right? So I'll just let this run just for a bit. Ignore that low disk space. I should probably delete the volume. I created a volume for my storage test. So 170 seemed to be like what we peaked at there, 170 times 8. It's about 1.3 gigabits per second. 175. So again, if I let this run for a little bit. So it's 187 now. So even if I said we're at 191, so even if I said we're at 200, oh, it's 197 right now. So we'll give it a few seconds. I'm going to let this run for a few seconds and I'll come right back. Okay, I seem to hit 183. So if it was 183 times 8, oops, sorry, 183 times 8 gives me about 1.5 gigabits per second, right? So if I'm, whatever, so about 1.5 gigs per second throughput. Now, let me just stop this because I know it's stressing probably the CPU and stuff. Actually, no, I should let it go. Let's continue. Let's let it do its thing. If I go back to my Iometer, oops, sorry, right over here. If I go back to ESX top, I should say, you actually see now. We got the Win VM here, and we see the packets transmitted and received, but we also see the megabits received here. So you hit about 2.8 megabits received on that, and then this one here is transmitting megabytes. So we're about 2.8 over here, about 3.0, that type of thing. So probably a little bit more accurate looking from this perspective. So I'm hitting about 2 megabits per second on my receiving. The other one's doing a lot of writing. So these numbers are very close to each other. Again, notice here, again, these guys are bound to VMNIC 0 in this case, in my lab environment. And notice VMNIC 0 is not really doing a whole, it just spiked there. Actually, did it? Yeah, it just spiked just a little bit, right? Let's leave it alone for a second. Yeah, so no, we're doing it. It's not doing like the exact same amount as, see how that's much lower than this value here, the megabits per second. It's because, remember, the two VMs are on the same port group, on the same host, so we're not using the physical NIC to go to the outside world to talk, okay? So that's why it's higher. If they were on different hosts, that VMNIC 0 would also be saturated as well. So it's a way of you telling, okay, if your physical NIC is actually saturated. And generally speaking, if your NIC is a gig, whatever your speed of the NIC is, 80% is usually the saturation number, because you generally don't always get 100%. If it's it's a 1 gig NIC, you're not going to get generally 1 gigabit per second throughput. You're going to get very close to that, but you should consider it saturated at 80%. So 800 megabits per second, you're pretty much saturating your 1 gig NICs. Right now, let's go back into the machine over here. I wonder why the throughput's not faster. Let's stop this so I can actually do something. Right. I'll notice it here. It just went to 259, so 260 megabits. So let's megabyte 260 times 8. Sorry, 260 times 8. About 2 gigabits per second, which we were kind of seeing. Okay, so roughly about 2 gigabits per second. Let's look at this. Let's go into the network card of this guy. Network card connected. Let's go into change Ethernet adapter options, and you see here it's an Intel whatever number, a gigabit Ethernet. If I double click on this, you see it says it's a gigabit speed. So again, that doesn't really matter what that says there. Remember, this is a virtual NIC. Okay. Now, why doesn't it say VMX-Net 3? This is a Win 10 machine, so it defaulted to an E1000 card. Let's go into here. Let's right click on one of the VMs, edit settings, and you'll see network adapter. It's connected to production. And you see over here, it's grayed out. It says E1000E, and I can't change that. Well, now I should shut this down. So let's shut down these guys. Let's shut them down and change it over to the VMX-Net 3 driver, right? How do we do that? Let's shut it down. Let's do the same thing with Win 2. So let's wait for it to shut down. I'll pause the recording so you don't have to sit here and watch this. Okay, so they've both shut down. Let me just close this tab here. Close tab. Close tab. So they both shut down. Let's right click on one of the VMs. We'll do Win 1. Edit settings. And again, under network adapter, you'll see it's still grayed out. It won't let me change it. So you can't change it. One way to do this is to remove the network adapter and then add in a new one and put, so that's what I'll do. So I'm going to go into here, remove device. Remember, it's connected to production. I'm gonna basically say add new device, network adapter, and then again, notice it just kind of defaulted to production for me. Great. And then notice now it's going to let me, notice how it defaulted to E1000E. Now again, that depends on what operating system you selected when you created the VM. So I'm just going to pick basically the VMX-Net 3 driver. Okay. Notice if I pick pass-through. Pass-through allows me to assign a physical card to the VM, right? I can't do that. I'm in a nested environment. It won't let me do that. So I'm going to pick VMX 3. I'll say, okay, I'm done. And I'm going to power on that VM. I'm going to repeat the process for VM2. So let's see if we see an improvement using the VMX-Net 3 driver. All right, so let's get rid of this NIC. Actually, let's first of all look at it. Again, it still says E1000. Great. That's for Win 2. Let's remove the device, add a new device, network adapter. And again, let's change this to VMX 3. Say OK, and then I'll power it on. So I'll let them power on. We'll come back after it settles down a little bit. They probably going to have different IP addresses, but we're going to do the same thing. Okay, so I'll pause this recording. See you in a bit. Okay, so we booted up both Windows 1 and Windows 2. I've opened consoles to them. Let's just check and make sure everything's been set up properly. Let's just go into my network connections here. Let's look at here, network connected. And you'll actually see under, let's go to change, I should say change adapter options, sorry. Let's go back in here, change adapter options. You'll see it says VMX3. If I double click on this, you see it says 10 gigabits per second now, the speed. Again, I don't know if that really means anything, but anyways, we'll just leave that alone. I'll close that, close that, close that. Let's start up Iometer or Iometer, however you want to pronounce it. All right, so I'll leave that going. Let's go over to Win 2. Let's get to our network here just to make sure everything's all, let's go to adapter options. And again, you see it says VMX3. If I double click on this, you see 10 gig. Again, doesn't really matter. But anyways, it is the VMX3 drivers that we're using now. So let's close all that. Let's fire up Dynamo over here. yes. And it's connected to Iometer. Give it a few seconds, and there we got some workers here. These are for disk. I'm going to get rid of them. I'm going to get rid of these two workers as well. And then I'm going to add in a network worker, which is this icon. So we'll add that. And I'm going to say this is 163, and it's going to go to 173. We'll say access specification. Let's go to that 4 kilobyte aligned, 100%. Let's edit that. Let's do, instead of random, I want to go all the way so it's sequential. See, it's 100% reads. It's all sequential. Same stuff as before. We'll see OK. We'll add that to this worker. Great. And then we'll start the test, and we'll say OK to save that. And then right now, just change the update frequency to 5 seconds. And we can see that's cranking up quite a bit now, right? So if I just leave this for a little bit, we'll let this run just for a little bit and take it from there. So significant improvement here, right? So we're at 1.6 gigabits per second. Sorry, 1.6 gigabytes per second, right? So you do the math on that. It's fairly high, right? Actually, let's get this, just multiply it by 8. Let's go to here, and you see we're at 6.8, so almost 7 gigabits per second. Again, it's kind of fluctuating here a bit, right? I should actually do just reads only. Megabits per second reads. All right, so 822. So 8 times 8 is about 8 times 8 is about 64. So roughly about 6.4 gigabits per second throughput. A little more than that we're seeing. If we go into ESX top now, we'll see Win 1 is on this NIC here, and we see Win 1. If we look at the megabits per second reads, we see about 6.7. We're hitting 8, which is kind of peaking around there, right? So we're seeing it's doing a lot of reads as opposed to writes type of thing. And again, we see that's a fairly high amount of traffic going through that NIC, and this VM is bound to VM NIC 1, which is the physical NIC on my ESXi host. We know that's a virtual one, but anyways, apart from that. And if we look at VM NIC 1, it's really not doing anything, to be honest with you, right? You know, there's really not much going through there compared to what's up here type of thing, okay? And it's fluctuating a bit. So significant improvement. So what did we see there? We see a pretty significant performance. We got about 6 gigabits per second, and I'm probably not stressing the crap out of it either, right? We got 6 gigabits per second compared to 2 gigabits per second. So again, one of the reasons why you should always try, if you can, to use the VMX 3 drivers, okay? Inside your VMs. That's about it. Actually, no, there's other stuff I just want to show you. Remember, again, depending on the virtual switch the VM is connected to. So if the VM is connected to a distributed switch, which it is in this case, you can actually go in and let's go into the production port group. I can go into production and I can edit the settings, and I could actually go into traffic shaping. And remember, I could actually specify if I want to enable ingress and if I want to enable ingress and egress traffic shaping, I could do that. So I can limit what goes into or out of that port group if I want to, right? You could also go to your your VMs. Let's go to your VMs. You're gonna let me edit here? Probably not. Let's go back into the close view. Let's go into Win2 is doing the thing. I can edit settings here, and under my network adapter, again, this is where you can actually go in and put reservations, shares, and limits. Now, I talked about that in my resource monitoring lecture, so you may want to take a look at that. But I could put actually limits here if I want to, and that would put a limit on how much that VM can transmit out. So if I wanted to also, if I notice, that VM's basically chewing up on my bandwidth, I could actually maybe put it on a separate port group, or I could put a limit on how much it's allowed to push out onto the network. Okay, so you have that as an option as well. Oh, the other thing I want to point out here is if I go to my networking view on my distributed switch, if I go into configure system traffic, this is network IO control. This is where, again, you can specify shares, limits, and reservations. And this comes into play is if you're competing for NICs. Let's say I only got 2 network cards in my host, okay? And I've got my VM traffic, I got my vMotion, vSAN, all that stuff. You could actually go in here and say, I want to adjust who gets higher priority to that, and you actually see that over here. Again, you can set reservations, which again, reservations, it's a bit of a dangerous thing. I talked about that in my resource pools lecture, so you want to take a look at that. But you can also specify limits as well on if you don't want, let's say your let's say you don't want your vMotion traffic sucking back all your bandwidth. You can edit it and say, okay, I'm going to limit my my vMotion traffic to whatever 1 gigabit per second, let's say, instead of 100 gigabits, whatever the case may be. I'm just throwing an example out here, right? Again, I'm not a big fan of reservations, to be honest with you. You can do reservations of your, so if I get 2 10 gig NICs, I could do a reservation of total of 7.5 gig, okay? 2 10 gig, yeah, 7.5 gig. Again, reservations can really come back to haunt you if all of a sudden your host fails or you're trying to power on VMs and stuff. So I try to stay away from it if I can, unless if you can't, you can't, right? But especially if you have to do SLAs, right? But anyways, other ways that you can manage your traffic here, okay, folks, is with these shares, limits, and reservations, network I/O control. So some pretty cool stuff. I think that's about it for the most part. The networking stuff's pretty straightforward. You're looking for drop packets. If you're dropping packets, your performance is being affected. Also, if you're hitting 80% of your network card speed, your performance is being affected by it, okay? And I talked about, the type of teaming that you can do, and I mentioned that in our networking video. But anyways, I hope you enjoyed this. If you found this useful, again, please give it a thumbs up, or if you found it entertaining, give it a thumbs up. Please support the channel by subscribing to it. I'd very much appreciate it. And leave comments and questions down below. Let me know if there's something you want to see or do. I keep getting a lot of comments on certain things, and that's great. I love it. And I do have limited resources, and I'll try to get to all the stuff that you folks are requesting. But that's it. Thanks very much. You have a great day. Bye now.